Okay, in this video I'm going to show you how to write nuclear decay equations to represent the process of unstable atoms falling apart. There's two general ways this happens. You can have a large nucleus that will break off a little alpha particle, which as we know is 2 protons and 2 neutrons, leaving behind some slightly smaller and somewhat more stable nucleus. Or it can go through a beta decay, in which case a neutron itself in the nucleus decays, falls apart to an electron, and leaves behind a proton. Let's see how this works as we're representing these in equations. All right, so it says californium-249 is an alpha emitter. All right, so what that means is that element, californium-249, goes through a alpha decay. And as we know from class, an alpha particle is just a helium atom. And we want to know, well, what is this going to turn into? In other words, if this is the californium and there's a little helium alpha particle that came off, what's left behind? Well, the helium is 2 protons and 2 neutrons. That's why there's a 4 mass. So if we started out with 249 units of mass and 4 flew out of the nucleus, then we're left behind with 245. Now 245 is the mass number, but the atomic number is now 96. We had 98 protons. We lost 2 of them that went flying out in the alpha particle, left behind 96. And if you look on your periodic table, 96 is the element curium. Now it turns out curium is also unstable. And so curium will also decay. And that's why this is called the californium chain, because californium will decay into curium, but that will then also decay. And again, curium is an alpha emitter. That is, it decays into with an alpha particle. 24596 is curium. That falls apart into an alpha particle and something else. The something else is going to have a mass number of 241. That way, the mass of 4 and 241 gives us back what we started with. The atomic number goes from 96 to 94. We lost 2 protons. 96 protons minus 2 protons leaves 94 protons. And we can look on our periodic table to see the element that is. Now that is also unstable, and so that will decay. And again, this is why it's kind of a chain. This decays, and then this thing decays, and now the new element decays also. Now the new element goes through a beta decay. So here's what a beta decay looks like. In a beta decay, a neutron falls apart, an electron gets ejected out, leaving behind a proton. That means the nucleus has 1 more proton than it had before. We write this like this. There's our beta particle. The electron has no mass, and it has an atomic number of sort of -1 in this case, because what that really means is we have 1 more proton than we had before. 241, and this goes to 95, because we have 1 more proton now than we had before. The electron left and left behind a proton. And that is the element americium, which is also radioactive, and the chain will continue. Okay, so that is the basic process for writing a nuclear decay equation. And if you follow this to the bottom of the page, the very last one will be end up with a stable atom. And a key for this will be on the Moodle website.